are there. You try first. At least 1 hour you spend at home. So you will go through that 1 to 40. Some of them question easily, you will definitely solve it. Some of them you not get. You ask me doubts that we will discuss tomorrow. Okay. Clear? Question number 1 to 40, do homework it is. Module 4, page number 18 to 21, question number 1 to 40 you do. Okay, doubts are there, we will discuss in the class. Tomorrow I will discuss the doubts regarding your practice today. So that I will discuss tomorrow. Okay. So now we will discuss basic practice questions for the atoms only. General questions other apart from your module. Okay. Boys and girls, is it clear what you need to do the work at home today? Clear? Boys, is that homework point is clear? What you need to do today, atom chapter? Yes or no? Tell me. Right. Look here. So how I said yesterday for dual nature of matter, we'll say a brief of formula and what type of question they will ask, how to solve it. So let us some few example also we'll see. Okay. For atom chapter we'll see now. Okay. So homework is clear everyone, right? That you are going to be practice and any doubts are there you are asking tomorrow. Right. See, look here. Basically, Rutherford alpha particle scattering experiment, gold foil experiment. That is all. That is when alpha particle bombard means hitting, collision. Alpha particle is bombarded with the nucleus of a gold or nucleus of anything, but Rutherford finally concluded by using gold foil only, gold nucleus only, right? But here, from that what we observed, the question they will ask, which area in Rutherford alpha particle scattering experiment they will ask me? Two things already I told. One is, at this particular angle, number of scattering particle, number of scattering alpha particle, how to calculate? Because when alpha particle bombard with the nucleus, bombard means hitting or collision with the nucleus. So nucleus has a positive charge, already I said. Alpha particle also has a positive charge. Due to this repulsion force, between the repulsion force, some of them deviating and some of them 1 in 10 lakhs it bouncing back, and some of them deviated more than 90 degrees, some of them deviated 0 angle also, undeflected. So based on that, Rutherford said that most of the atom is empty and only most of the atomic mass, total most 99% of 99.9% of mass of atom extremely occupied in a small space. That is only nucleus is named. Extremely small space or small area, small volume it is occupied, that named as a nucleus. And later nucleus has proton, neutron, that is different. Okay. Because of nucleus possesses positive charge, that's the reason alpha particle are deviating. Some of them are deviating, some of them are not deviating. Some of them are highly deflecting with 180 degrees, more than 90 degree, and most of them are passing through the new atom without deviation. So this is indicate that atom, most of the atom is empty space, hollow, inside empty, hollow, right? So that is Rutherford experiment actually. Okay. So based on that, one formula is scattering of alpha particle, that is n, number of alpha particles scattering at particular angle theta is directly proportional to 1 by sine to the power 4 theta by 2, sine to the power 4 theta by 2. So we know n is number of alpha particles scattering at this angle of theta, scattering angle theta here, scattering angle theta. At this angle of scattering angle, the number of alpha particle is n. So n is directly proportional 1 upon sine to the power 4 theta by 2. Clear? Right. Then second thing, while in alpha particle scattering experiment, while alpha particle is bombarded, alpha particle is moving. So how much closest distance it will go, or how much nearest distance in nucleus it will go? How much near distance the alpha particle can go before it is stopped? Before it will stop because of repulsion force. So that is called closest to distance approach. Closest to distance approach. For the closest to distance, for closest distance, so what we will equate kinetic energy of alpha particle is equal to potential energy of between alpha and nucleus. Correct? This will equate and will calculate the closest approach distance. Concept of closest approach distance, because initially kinetic energy is there, finally alpha particles stop close to the nucleus. So what is that closest distance between the nucleus and center of the nucleus and the alpha particle is called closest to distance approach. At that point, alpha particle comes to rest. So nucleus, the distance between them, that only we call closest approach distance. So initial kinetic energy of alpha particle converting into potential energy between alpha as well as nucleus at that point. So kinetic energy converted into potential according to conservation of energy. Kinetic energy of alpha is what? Kinetic energy of alpha is half mv square, you can write. Okay, that is equal to k, that is 4 pi 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught k q1 q2 by r square, right? K q1 is the alpha particle charge, that is 2 into e, and mass charge of nucleus, that is z into e, by distance between them d, k q1 q2 by d. So from here we can calculate what is d, closest approach distance. Okay, and after calculating d, they may chance us asking impact parameter. What is impact parameter? Basically, impact parameter is a perpendicular distance between initial velocity vector of alpha particle to the center of the nucleus. How much perpendicular distance is there between center of the nucleus to initial velocity vector? Initial velocity vector. So that impact parameter is impact parameter, that is denoted by B, and it is d by 2 cot theta by 2. D by 2 cot theta by 2. D is the closest approach distance that you can calculate it from here, and theta is a scattering angle. Scattering angle. Clear? Yes or no? So this Rutherford alpha particle scattering experiment or Rutherford atomic model, these are the area of numerical question they may ask. One is scattering angle, number of alpha particle scattering, and closest distance, and impact parameter. If this is clear, tell me. Student, this is clear? Any doubt in this one? Clear, na? So we'll do practice of questions based on this. Okay, so look here. Right. The question will do it from this. Look here. Look here. The question is, see how they will ask. I will ask, tell me whether you are able to do or not. Based on this, the number of scattering particle, number of alpha particle scattering at 60 degree, number of alpha particles scattering at 60 degree, some 10. What are the number of alpha particles scatter at an angle of 120 degree? At an angle of 120 degree. Can you calculate? Are you getting my point? Number of alpha particles scattering at an angle of 60 degree is 10. Then number of alpha particles scatter at an angle 120 degree, scattering angle 120 degree. Can you able to do or not? Yes or no, you tell me. Tell me. Can you able to do? Girls, tell me, can you able to do? Let us do that question only. Do everyone. Number of alpha particle scattered at 60 degree angle is 10. Find number of alpha particle scatter at 120 degree. Find out and tell me the answer. Everyone do and tell me the answer. Simple question only. The doubts you said, I said in the, when I start the doubt session, I asked many times, 10 minutes, I asked the doubts you have sent yesterday, you send again. But you may be not attending the class at that time. You have not sent, but till the last 15 minutes, you just remind me, I will discuss that. Anyway, but now do this question. Number of alpha particles scattered at 60 degrees 10. Number of alpha particles scattered at 120 degree. Tell me the answer. You need to do and tell me. Simple question only. How to do? Number of alpha particle directly proportional to sine to the power, inversely proportional to sine to the power theta by 2, right? So can I write n1 by n2 is equal to, inversely proportional is there, sine to the power theta 2 by 2 by sine to the power theta 1 by 2 into 4. Correct? So they given sine theta 1 is 60 degree, theta 2 120 degree. So I can write here sine 60, so second angle, right? So 120 by 2 whole power 4 by sine of theta 1 60 by 2 whole power 4. Correct? Yes. Sine 120 by 2 60 degree. Yes. Sine 60 by 2 30 degree. Yes. So sine 60 degree whole power 4 by sine of 30 degree whole power 4. We know sine 60 value root 3 by 2. Sine 30 value 1 by 2. So whole power 4 is there. So I can write it is whole power 4 mean sine 60 root 3 by 2. How many times? 4 times. Root 3 by 2, root 3 by 2, root 3 by 2 divided by sine 30 1 by 2. How many times? 4 times. 1 by 2, 1 by 2, 1 by 2. Correct? So this 2 will be cancelled out. 2, 2, 2, all these 2's will be cancelled out. Only left is what? Root 3 into root 3. 3. Root 3 into 3. 3. So 3, 3 is a 9. So finally, we are going to be calculate n1 by n2 is equal to root 3 into root 3, 4 times. That is 3 into 3, 9. Then n2 will be equal to n1 by cross multiply n1 by 9, 10 by 9. Actually, integer value should get number of particle, na? But process I am saying that. Clear? Otherwise, exactly number you want to get, take this one is something like 72. And this will come how much? 72 by 9. So 8. Exact number you should get. Because alpha particles, right? Fraction won't get. So, okay. But processor understood it. Process understood? Yes. Clear, na? Simple. Inversely proportional is there. Now, n is inversely proportional to theta. So, theta increasing means sin theta value increase. Basically, theta value increase, sin theta value increase. So, sin theta value increase means n is inversely proportional is there. So, sin theta increasing means n will be decrease. So, n decrease only. So, initially 72, finally 8 only. I change that. If anybody is seeing now, you can change. I value 10 I given initially, but I change into 72 because some exact number you should get because alpha particles, right? It is. So that's right. But anything you need to learn the process here. Clear? Yes. Next one you see based on this. Look. So question is given. Find the closest approach distance or closest distance between alpha particle and gold nucleus when alpha particle is moving with How much velocity means? That velocity is given 2.1 into 10 to the power of 10 to the power of 7 meter per second. Okay. So, and they given charge to mass ratio, they given, that is alpha particle charge to mass ratio m by, that is specific charge, q by m ratio they given, which is 4.8 into 10 to the power 7 coulomb per kg. Okay. Right. So this is the given, and gold atomic number we know it is 79. Right? Gold atomic number is how much? Z is 79. Correct? This is a given information. So what we need to find the closest distance approach between the alpha particle and the gold nucleus. Right? So closest distance means what we need to apply here. See, they have given it alpha particle is moving with this much of speed. So alpha particle is moving means kinetic energy is there. Yes. And gold atomic number is given. So we can directly, what will equate? Kinetic energy of alpha particle equate to the potential energy between the alpha particle and nucleus. K Q1 Q2 by D. That is closest distance will get. Can we calculate, yes or no? Formula you are getting, what we need to do? Kinetic energy of alpha particle should equate to the potential energy between them. Clear, na? What we need to equate, it is clear. Look. So find the closest distance. So will alpha particle, kinetic energy of alpha is equal to 1 by 4 pi epsilon naught Q1 Q2 by D. Correct? So kinetic energy of alpha m into V square. Correct? V is given how much? V square I wrote. Then 1 by 4 pi 9 into 10 to the power of 9. 1 by 4 pi epsilon naught value. Q1 charge of alpha, that is 2 into E into Q2 charge of gold nucleus, which is Z into E, that is 79 into E. Correct? By D. The D value we need to find. Correct? So now can I write here? So of M is, we don't know. V square value is given 2.1 into 10 to the power of 7 whole square, which is equal to 9 into 10 to the power of 9. E into E square 2 into 79. 79 means how much? 158 into E square. Clear, na? E square by D. D that we need to calculate now. So, but there is given mass, charge to mass ratio of alpha particle is given, right? Alpha particle, charge to mass ratio. Charge to mass ratio means this is a mass of alpha particle, we know, because it is a kinetic energy of alpha. Here E is the charge of proton. Charge of proton. So charge of mass ratio of alpha particle means, what is the charge of alpha particle? 2E. 2E is the charge of alpha particle. So I can write here, 2 I can write here. So that means D, I can write D equal to directly 9 into 10 to the power of 9 into 158 into E square by, this will come in 2 here and divided by M. Correct? Yes. So can I write this here for our calculation part? So this is also come in the denominator. 2.1 whole square into 10 to the power of 14, 7 whole square into M is there. So our conveniently I can write this one as 9, 14 cancel out. It will become how much? Nearly 5. Correct? And 2 into E I will write, this is 9 into 158 into E into 2E. Okay, by 2.1 whole square into 10 to the power of 5 into this I will write M here. Correct? 2 into E, 2e by m. This e already is there. 2e by m, mass, charge to mass ratio, this is given. Direct value we can substitute here. So that's the reason I wrote in that way. So 9 into 158 into 1.6 into 10 to the power of minus 19 because charge of electron by 2.1 into 2.1 10 to the power of 5 into charge mass ratio is 4 into 10 to the power of 7. 4.8 into 10 to the power of 7. So 5, 7, 2 cancel out. 2 minus 19 minus 17 is left. Now remaining this much. 9 into 158 into 4.8 divided by 2.1 into 2.1 into 10 to the power minus 17 meters. If you simplify, you'll get the answer. Closest distance. How much? I'll calculate and say. Two into 158, right? 9 into 158 into 4.8 divided by so nearly 1547 it is coming. So nearly 1548 into 10 to the power of minus 17 meter. This is the closest approach distance. Calculation part, you need to practice that one. Okay. This is clear now. Just only thing is you need to equate kinetic energy of alpha particles should be equal to kinetic energy of, kinetic energy of alpha particles should be equal to the potential energy between alpha and the nucleus. That is a concept of closest distance. At a closest distance, kinetic energy of alpha particle 0, and initially separation is very large because nucleus at 10 to the power of minus 15 meter and alpha particle at initially start also 10 to the power of minus 10 if you take atomic starting point. So 10 power 5 meter distance is there. So infinity distance you can consider. So initially potential energy 0, finally kinetic energy 0. By applying conservation of energy, kinetic energy of alpha is equal to potential energy of system. Is it clear now? Why 2e means there I said somebody asking me that question in why 2e. Q1, Q2 we have to write for potential energy, right? Q1 is a charge of alpha particle, Q2 is a charge of nucleus. Charge of alpha particle is what? Alpha particle 2 protons will be present, only 2 protons, right? So 2 into E. In nucleus, charge of nucleus, just now in the morning class we studied. Charge of nucleus is what? Z into E. So Z into E. Alpha particle and nucleus, right? Alpha particle fixed, which is 2 into E. Then Z into E is for nucleus. In this situation, Z is 79, so 79 we substituted. Some other situation, Z is different value will substitute. Clear? Everyone, this question is clear? Tell me. Yes or no? Alpha 2e. Charge of alpha is 2e. 2 protons are there na, in nucleus of alpha. Right? So impact parameter is directly because D if we calculated impact parameter easily we can calculate D by 2 into cot theta by 2. The theta they will give in the question, just substitute in that. Is it clear? Alpha particle scattering experiment, how they will ask the question, and closest distance approach, how to calculate is clear. Clear or not? But somewhat calculation part, somewhat lengthy only present, that you need to practice, because calculation like this only present. So you need to practice more. So you will get an idea on how to simplify that. Clear? Calculation part will be present. Modern physics means calculation only. Formula based calculation will be more. Formula direct application and calculation part practice. Clear? In the next topic of that atom is Bohr model only. Majorly Rutherford this much of area only. Either number of alpha particle or closest to distance they will ask. Closest distance means directly apply the concept of kinetic energy to the potential energy. And impact parameter d by 2 into cot theta by 2 directly. The next Bohr model, in that Bohr model, radius, velocity, they will ask. Correct? What is in that Bohr model? What is their radius? R is equal to 0.53 n square by z angstroms in angstrom, right? Velocity 2 into 10 to the power of 6 z by m velocity in meter per second. Correct? Then once we know radius and velocity, you can find acceleration, time period, frequency, etc., etc. But mainly remember these two one, radius as well as velocity. Clear? The next important one, energy. Energy E minus 13.6 z square by n square. Right? 13.6 minus 13.6 z square by n square. So negative sign indicate in the total energy of electron in particular orbit. Total energy of electron in particular orbit. Okay. Negative sign indicate that it is bound to the nucleus, or it is bound, the electron is bound to the nucleus. A strong attraction force is there between the electron and nucleus. So that's the reason it is revolves around that particular nucleus, or it is revolves in that particular orbit. So strictly bound to the nucleus, it is negative sign indicate. Like our gravitational potential energy between the earth and the Mars is negative. That also indicate that this mass is bound to the earth. Right? Attraction force is there, indicate that. Yes, because of electrostatic attraction between the electron and nucleus. So this is negative sign we got, minus 13.6 z square by n square. And we know kinetic energy. Kinetic energy is equal to total energy only, but positive sign. And potential energy will be 2 times of total energy. Correct? Right? So this is only Bohr model, this much only. But the numerical question, like electron jump from one energy level to another energy level. So what will be the electron energy means? So E can be written as, or photon energy basically. H nu or energy of photon will be equal to 13.6. I'll write here itself. Delta E or H nu is equal to 13.6 Z square into 1 by N1 square by N2 square. Then 1 by lambda wave number, it is directly we can write R into Z square 1 by N1 square minus 1 by N2 square. R is Rydberg constant, this is 1.1 into 10 to the power of 7. Then frequency. Frequency also we can write F is equal to RC. C into R. C is the speed of light. So Z square by 1 by N1 square 1 by N2 square. So this is the area of where they can ask numerical problem on based on these formulas only, not more than this. And I told that how many number of spectral lines will come when it is jump from one energy level to other energy level. Directly ground state means n into n minus 1 by 2. Otherwise n2 minus n1 plus 1 into n2 minus n1 by 2 I said. Right? So let us few questions we'll discuss based on this. So in this formula, any doubt is there? Tell me, simple only. Impact parameter, already we discussed what is called the closest approach distance, right? So impact parameter B is equal to D by 2 cot theta by 2. Theta is given 60 degree, for example. Then there is cot theta by 2 substitute, and D which we got calculated substitute will get it. Mainly closest distance you calculate. Then theta they will in the question they will give. Just substitution only, nothing else. Now this one, anything, any doubt is there in that? You need to remember these values ultimately. Then if you remember this Rutherford, that is atomic question, atom chapter question, you can do it if you remember this. One is Rutherford values, that impact parameter and scattering particle, and Bohr model, this one. If you remember, you can calculate. Any doubt in this equation? Tell me. Girls, any doubt in this one? Right, find out simple question I'm asking. Like, simple question. Find the radius of second orbit of He plus atom. Find the radius of second orbit of He plus atom if radius of H atom, first orbit of radius of first orbit of H atom is 0.53 angstroms. So first orbit of H atom is given, radius of first orbit of H atom is given. They want to calculate radius of second orbit of helium plus atom. Second orbit of helium plus atom. So find out it. Simple. Radius of first orbit of H atom is given. Second orbit of helium plus we need to calculate. Find out yourself first based on here. In front of you, formula is there. Calculate. So what formula we need to apply? This one only, because n square by z. So z is H atom and n is z and n for H and helium will substitute. Right? So can I write here? R is directly proportional to n square by z is there. Then R1 by R2 is equal to n1 by n2 whole square into z2 by z1 whole z only, n square by z, right? So n1 by n2 whole square, z2 by z1, inversely proportional, because R is inversely proportional to z, directly proportional to n square. So n1 by n2 whole square, z2 by z1, inverse. So what is R1 means? We'll take R1 is for hydrogen. R1 is 0.53 angstrom. R2 we need to calculate. Z1 is hydrogen. R1 we consider hydrogen, right? Z1 also hydrogen only, 1. Z2 helium 2, right? Then N1 for hydrogen 1 at first orbit, right? For helium, second orbit they mentioned. So every value we have. So can we able to do this? Yes. R1 by R2 is equal to N1 1, N2 2 whole square, Z2 2 by 1. That implies 1 upon 4 into 2 by 1. So 1 cancel, 1 by 2 it is. Nothing but R2 is equal to 2R1. Correct, na? Cross multiply scale. So R2 into 2R1 means R1 is given 0.53. So it becomes 1.06. 1.06 angstrom. The radius of second orbit in helium plus. The radius of second orbit is 1.06 angstrom. 1.06 angstrom. Clear that question? Any doubt? Is it clear or not? Clear, na? Next, one more question you see. One more question. Find energy of electron in second orbit of lithium 2 plus. Find the energy of electron in second orbit of lithium 2 plus. Okay. So energy of electron in that we need to calculate, and okay, energy of electron of lithium. Thereafter you can find, once you get energy, you can find kinetic energy, you can find potential energy also. Okay. So find the energy of electron in second orbit of lithium. Second orbit of lithium. Tell me what is lithium atomic number? Because energy we required. Now energy is what? E is equal to minus 13.6 Z square by N square. So energy is equal to minus 13.6 Z square by N square. N is given 2. So Z is required. Lithium. Lithium atomic numbers. How much? Simply calculation only, right? Atomic number we need to calculate. Lithium how much? 3. Correct? Substitute and get the answer. Do it. Simple question only, not difficult. So Z of lithium is how much? Minus 13.6. Z of lithium is 3 whole square by N square. N square is 2. 4 whole square. So it becomes minus 13.6. 9 by 4. Electron volt it is. Total energy. Then if they want, finally they want to calculate what is kinetic energy. Kinetic energy is what? We know for any state of electron, kinetic energy equal to total energy only, but positive. Potential energy equal to 2 times of total energy. So I can write here kinetic energy of that electron will be 13.69 by 4 electron volt. Positive, see this is negative, this is positive. Then potential energy will be 2 times of total energy. 2 times means 13.6 into 2, how much? 27.2, right? Minus 27.2, 9 by 4 electron volt. Yes or no? This is a method. That means sometimes they will ask, what is the ratio of kinetic energy in lithium second orbit to helium third orbit? Ratio of kinetic energy. Ratio of kinetic energy is what? Nothing but ratio of energy only. Kinetic energy equal to total energy only, but positive. So if you take ratio of negative, negative anyway cancel out. So ratio of energy only, ratio of kinetic energy. Clear? Find the ratio of kinetic energy of electron second orbit of the lithium to the third orbit of helium. Can you find? Yes, simple. Ratio only we have to take z square by n square ratio. Clear? Answer in electron volt. EV means electron volt. See, one more question you see. Example. Find the wave number and wavelength of photon when electron jump from or otherwise directly photon of second line second line of Balmer series. Find the wave number and wavelength of photon of second line of Balmer series. Wavelength and wave number we need to calculate for which one? Second line of Balmer series. Second line means what? Balmer series start at first excited state. So any electron transition from higher to second excited state, first excited state, second energy level or first excited state. So that we call Balmer series, right? Second line means what? From where to where the transition is taking place. See, Balmer series means n equal to 2, it will start. And second line means, this is first line, right? N equal to 3. And this is second line of Balmer series, that is n equal to 4. Nothing but the transition is making from n equal to 4 to n equal to 2. Indirectly, second line of Balmer series means what? N equal to 4 to n equal to 2. First line means n equal to 3 to 2. Third line means n equal to 5 to 2, like this. And already we said maximum and minimum. Maximum means this one. Minimum means infinity you have to take. Then in this situation, what is the formula? Wave number or wavelength 1 by lambda is equal to R into of H atom only take. H atom. Because the atomic number also required. Na? H atom only, hydrogen atom. R into 1 by N1 square minus 1 by N2 square. Right? So we'll substitute R value 1.1 into 10 to the power of 7. 1 by N1. N1 is 2 square minus 1 by N2, that is 4 square. Clear? So that is equal to 1 by lambda, that is equal to 1.1 into 10 to the power of 7. Denominator 1 by 4, 1 by 16. So LCM will be 16. So directly I am doing 16. This is 4 minus 1. So this is become 3 into 1.1 into 10 to the power of 7 by 16. So nearly 3.3 by 16 into 10 to the power of 7. Correct? Or it can be written as nearly. 0.2 into 10 to the power of 7. This is 1 by lambda, wave number. 1 by lambda only wave number, right? So wave number can write as 2 into 10 to the power of 6 also. These many waves. Wave number this much. Then wavelength is what? Lambda is equal to reverse 1 by 2 into 10 to the power of 6. Nothing but 0.66 into 10 to the power of minus 6. Correct? Meters. Question you understood and solution you understood. Simple only. Only thing is what is second line of Balmer series we required. Second line of Balmer series. Second line means n equal to 4 to n equal to 2. Yes. Third line means 5 to 2. Girls, or you are not responding? You are there in the class or not? Is it clear what I discussed till now? Any doubt? Clear? Then one more question I will say. You tell me yourself, you tell me the answer. Right. See, find the number of emission lines possible for electron jump from third excited state to ground state. Find the number of possible emission lines when electron jump from third excited state to ground state. Third excited state to ground state. Number of possible lines, emission lines, which will be how many if the electron jump from third excited state to ground state? Tell me, simple question only. Calculate. So third excited state to ground state. Third excited state means what? Third excited state. That is n equal to 4. Ground state. N equal to 1. Ground state is n equal to 1. Third excited state means 4. So that is make electron transition is from 4 to 1 is coming. So I told that direct formula for electron make higher energy to ground state. Number of possible emission lines will be directly number of emission lines. What it is? N into n minus 1, right? By 2. If it is made directly from higher to ground state, directly ground state. So n is the higher energy level number it is. So n equal to how much here? Ground state is anyway 1. So n equal to how much higher energy level? 4. So directly we can substitute number of possible numbers will be 4 into 4 minus 1 by 2. So 3, 4 minus 1, 3, 3 into 4, 12 by 2, which is 6. So possible numbers will be 6. Number of possible emissions when transition make from third to ground state is 6 number. In the yesterday class I said, right, how we did this 6? Because n equal to 4 to n equal to 1 it is coming. It may go directly from n equal to 1 to 4 to 1, or it may come to 4 to 2 and 4 to 3, or directly 4 to 3 to 2 also. Combination these are. So 6 number, total number possibility will be 6. Is it clear now how to calculate number of possible lines, emission lines? If it is not ground state is not there. Suppose, assume, I'm not discussing the question, but assume this is not ground state. For example, this is something like first excited state is given. First excited state. N equal to 2, right? First excited state means, so at that time number of possible number will be N2 minus N1 plus 1 into N2 minus N1 by 2. This is the formula. If it is ground state, directly N into N minus 1 by 2. If it is what you call any other state, not a ground state, then directly this N1, now it is become N1, this is N2. Right? N1 and N2. We can do it this. N2, 4 minus 2. 4 minus 2. How much? 2. 2 plus 1, 3. And 4 minus 2, 2. 3 into 2, 6. 6 by 2. 3 will come. Clear? Like that. If it is not a ground state, this one. If it is ground state, directly this. You can apply this also, you will get ground state. Because N1 become 1, it will come. But remember, for ground state, direct N into N minus 1 by 2, where N is a higher energy level. Student, is it clear? Yes. So somebody, this is about atoms. So what you do today, the module question which I given 1 to 40 questions I've given, right? You try at home, right? So whatever the doubts are there, tomorrow doubt session or tomorrow class will discuss. Okay, not only atom doubts, you have any doubts regarding dual nature and atoms, we will discuss. But strictly, already you practice the atom dual nature, so today you practice atoms. So any doubts we will discuss tomorrow. And somebody sent the doubts I'm going to be discussed now. So they sent it. What is the doubt? First question you see. First question is given that a photocell employs photoelectric effect to convert change in the frequency of light into change in the electric current, change in the frequency of light into the change in kinetic energy, change in the intensity of illumination into change in the photoelectric current, change in the intensity of illumination into change in the work function of the photocathode. Because their flashlight will get photocell, we have to photocell conversion of electron energy into kinetic energy, right? Photocell means light energy. Basically, it is what? Energy converting into same photon will be fall, means intensity it is. So C option is correct. Photocell. Next question. For photoelectric emission from certain metal, the cutoff frequency is nu. If radiation of frequency 2 nu impinges on the metal, that means applied on metal plate, the maximum possible velocity of the emitted electron will be maximum possible velocity they are asking, right? So photoelectric emission from certain metal cutoff frequency means threshold frequency is nu. Then what is the radiation if frequency 2 nu is fall? What is the maximum possible wavelength? Sorry, velocity. So they have given threshold frequency is nu they given. That is work function you can calculate h nu minimum. That is given h nu only. And incident energy h nu, that is directly they given h nu into 2 nu they given. Minimum free double they given. So that is 2 into h nu. Correct? Yes. Then we need to calculate what is maximum possible energy they are asking. Maximum possible velocity. So of m v max square, that is kinetic energy maximum, is equal to h nu incident energy minus work function. So this is 2h nu minus h nu, it become h nu. This is 1 by 2 m v max square. Then what we can do here, v max square become 2h nu by m, just conversion, root. So proportionality they are asking. So maximum possible will be what? 2h by m, root over 2h by m, root over 2h by m. Because nu is the incident threshold wavelength, threshold frequency given. So nu is the threshold frequency, means nu for that particular metal is constant only. So only 2h by m it is depends. So answer is 2h by root over 2h by m. Answer is 2h by m. Next. The next question they given, the work function of a surface of a photosensitive material is 6.2 electron volt. The wavelength of incident radiation for which stopping potential is 5 volt they given. Simple. Stopping potential, that is kinetic energy maximum, is EV naught is equal to energy of incident photon minus work function, right? Correct? So photosynthesis work function is given 6.2 they given. So work function is 6.2 they given. EV naught is equal to E minus 6.2 work function is given electron volt, and V naught is given 5 volt. Then kinetic energy become what? How many volt is there? That many electron volt kinetic energy will come. Right? So this is directly 5 electron volt we can write. So energy of incident photon will be how much? 5 plus 6.2, which is 11.2 electron volt, which is incident photon energy. But wavelength they are asking. Wavelength means we know hc by lambda is equal to 11.2. then lambda is equal to 12400, HC value 12400 by 11.2 angstrom will come answer. So if you cancel out, it will nearly 11.2, 11 2 is 121, right? So this is 2, if you take, nearly 2 will come. No. So it is nearly 124,000 by 1 and 2. So one point something will come. So answer you can select 1 point something. There will be options are given in the question. So in which region it is fall, they are asking. So this can be written as it is angstroms, right? So 1000, nearly 1000 angstrom is coming. So 1000 angstrom is falls in which one? Ultraviolet radiation. Because X-rays, infrared, visible region is given. So visible is above 4000, 4000 to 7000 or 8000. But nearly we are getting 1000 here because 124,000 by 112, nearly 1 point something only will come. So nearly 1000 means what? It is equal to ultraviolet region. X-ray region, no. X-ray is up to 100 angstrom only. So ultraviolet region, that will. Next, in which of the following emission of electron does not take place? Thermoionic emission. Thermoionic emission means by thermal energy electrons emitting. That is electron emission only. X-ray emission. Photoelectric emission, secondary emission. X-ray emission only. X-ray is a reverse process of photoelectric effect. Whenever certain wavelength, certain photons or certain wavelength of photon falling on the metal surface, electron emit in photoelectric effect. Correct? But X-ray is a reverse process. When electron fall on the surface, X-rays will be emit. Certain photon will be emit. Certain photon will be emit. Reverse process of photoelectric effect. So in X-ray emission, X-rays only emitted, not electrons. So X-ray emission. Answer is which of the following is not electron emission means X-ray emission. Thermoions. Electrons. Clear? The last question you see, there is given 2019 NEET paper, 2018 NEET question. 2018 NEET question it is. An electron of mass m with an initial velocity v naught I cap enters in electric field which is minus E naught I cap. Okay, at t equal to 0. If lambda naught is a de Broglie wavelength initially, then de Broglie wavelength at any time t they want to find. Simple question only. Look. Look here. Everyone look at the board. Question it is. What is the question they given? Means electric field they given it as E is equal to E naught I cap they given. This direction electric field is there. Which direction? Minus here there. Minus E naught I cap direction is there. So that means negative X direction is there. So that means electric field is there like this direction. Okay. Electron initially traveling V bar is equal to V naught I cap they given meter per second initially. Initially which is moving along X direction. Positive X direction is moving. Correct? Yes or no? Positive X direction, right? Okay, positive X direction. So, what is initial de Broglie wavelength they given initially? Lambda naught. De Broglie wavelength is what? Lambda is equal to h by mv. So initially what we can write? Lambda naught is equal to h by m initial. M initial is what? V naught I cap initially. So that means lambda naught is equal to h by mv naught. This is initial wavelength. But when this electron enter into this electric field, so definitely it will experience some force. Electric field will experience, electron will experience some force. So that force will be basically, force is equal to Q into E bar, charge into E. So we can write charge of electron is what? Charge of electron is E minus E, and electric field is along minus E naught I cap. So minus E naught I cap. Correct? So that means this is overall force become E into E naught I cap direction. Force is I cap direction is there. So force is equal to m into a, we can write mass into acceleration. Then finally acceleration of electron will be E naught by m along I cap direction. Along I cap direction. That means initially electron moving along I cap direction, and it is experience acceleration due to electric field also I cap direction. That means keep on velocity increasing. Keep on velocity increases. Yes, because of acceleration. And this acceleration is constant. Why? Because E is constant, M is constant, E naught also constant. Because that constant they given, constant electric field. So that means the electron will experience constant acceleration. So whenever a particle moving with a constant acceleration, so velocity at any time t second, how to write? Final velocity. So v is equal to u plus at, general equation, final velocity of any particle with acceleration. U, that is v naught initially, plus a, that is e into e naught by m into t. This is final velocity of electron at any time t second. At any time t second, this is a velocity. And initial wavelength is this much. So at any time wavelength you want to calculate, can I write at any time wavelength lambda, that is h by, at any time velocity, at any time t second velocity is v, m into v. So can I substitute h by this value, v naught plus e naught by m into t. Yes, simple. So from here, I need to convert in terms of lambda naught, because options are given in lambda naught only. So lambda h is equal to v naught, I will take common here because here m is there. M into v, right? In place of v naught plus e naught by m into d I wrote here. So what I will take from here, v naught I will take out. So what happens if you take v naught is taken out, m is already out is there. V naught I am taking out, right? V naught is gone, 1 plus E naught by m into V naught will come. E naught by m is already there here, and V naught we are taking out mean divide here. So V naught into T. But H by mv naught is what? H by mv naught is lambda naught. So finally I can write this one, H by mv naught as lambda naught. So that is lambda naught by 1 plus E naught by mv naught into T. This is wavelength at any time t seconds. Wavelength at any time t seconds. 2018 NEET previous year question it is. Good question only. Clear now? So option is A. A option is correct. If this question is clear, everyone, just look at the board. Any doubt you ask me? What we did here, simple. De Broglie wavelength is h by momentum. H by momentum for any moving particle. Here the moving particle is electron. Electron initial velocity given, that is v naught. And we know initial velocity given means initial momentum will have. So due to that initial wavelength, h by mv naught. This is lambda naught, the given. Now this electron is entering into electric field. We know charge particle enter into electric field, it will experience a force. That too, any charge particle enter into electric field, it will accelerate. Whether it is deacceleration or positive acceleration, whatever it, but it is accelerate. That means velocity will be changed. Velocity, magnitude of velocity changes mean momentum will change. Momentum changes mean de Broglie wavelength also changes. So based on that, we found acceleration by using F is equal to QE, and we got acceleration of electron. Then acceleration we got, and it is constant by using the concept of velocity at any time t second, that is v is equal to u plus at. We applied here, and v at any time t we got. Then lambda is equal to h by m into v at any time t, that is final velocity, h by mv. Then h by m into v value we put this one. Then we have taken m naught taken out here, taken outside of the bracket. So that means 1 plus EV naught m, V naught taken out means divided by V naught here. So final formula this one, final expression it is. Clear now? Any doubt? They are not asking the force, but they are asking the wavelength at any time t second. So wavelength changing because of speed or velocity changing. So velocity changing means because of acceleration. So acceleration how to calculate? From the force only. From the force only. So that's the reason we have calculated acceleration by using force. And that acceleration we have substituted in u plus at formula. A value is right. And then next simplification only. Clear now? Last step is what is there, you see, this is v is equal to u plus at. We know that constant acceleration, u, that is initial velocity, they have given v naught. A we calculated by using force, e naught by m, e naught by m into t is there. Now at any time wavelength, lambda is equal to h by m into v, final velocity I substituted v, that is equal to h by m. We have already here, we have substituted this one, this v naught plus e naught by m into t. So from this v naught we are taking out, taking common, v naught we are taking out here to convert this into lambda naught. So v naught I have taking out, already m is outside only, v naught we are taking out, and inside 1 plus ev naught, initially v naught not there, so taking out means divided with v naught, e naught v naught, e naught by mv naught into t. But h by mv naught according to initial condition lambda naught. This place I wrote lambda naught, remaining are divided. Clear? Right. So remaining of you practice the question today, the atom from module, and any doubts you ask me tomorrow. Right.